Alright, for section 4.8, you have a handful of story problems that'll probably give you a little bit of trouble. I'm going to show you three that are very, very similar to ones that you'll have in the homework. The first one I'm going to do is very similar to number 33, other than the numbers are changed. So you can read along. It says a surveyor wants to find the distance between points A and B. The bearings from A to B are north 48 degrees to the west, and the surveyor walks 38 meters from A at point C. So they're saying this is 38 meters. And it says the bearings from C to B would be north 71 degrees to the west. It wants you to find two things. It wants you to find the distance from A to B, and then it wants you to find the bearings from A to C. So again, almost identical to what you have in problem number 33. So what I suggest, anytime you recognize that you have a right triangle, and it's, I guess even if it's not off kilter, but you notice how it's kind of off kilter, what I like to do is I like to draw a rectangle around it, and I like to label as much information as I possibly can. Now the reason I draw a rectangle around it is because then I know I've got a bunch of 90-degree angles. And I should be able to play around with this and find a bunch of information. So I'm going to label the couple things that they gave me here. It said that the bearings from A to B is north 48 degrees to the west. So if I drew a vertical line here, north 48 degrees to the west, they are saying that this is 48 degrees. And then if I look at the second part of this information, it says that from C, so drawing a vertical line, which would be this one right here, from C, it's going to be north 71 degrees is what this angle would be to the west. So double check first of all to make sure that when you read that you can set up that. In the book they give you the picture. I don't think they give you those angles, but double check to make sure that you'd be able to set up those two angles. Alright, now that I've got those two, like I said, I'm just going to run through and use all the right triangles. I'm going to start filling out as much information as I can until I get some information that'll help me realize what you're looking for. I'm looking for this distance here. So I have one side of a right triangle. I either need to know one of these two angles or I need to find that side length. So like I said, I'm just going to play around with this thing until I run into some information that's actually useful. So for example, if you look at this right triangle, that's 71 degrees. Well, that means these two added together have to equal 90, so this little angle here must be 19 degrees. If I take a look at this being a right angle right here, if this is 48, that means this must be 42. Which means if I now look at this right triangle, there's 90, there's 42. That means these two have to add together to give me 90. That means this must be 48. And now if you look at it, I know that this is a 90 because I made a rectangle. Here's 48, here's 19. If I take 90, subtract those two numbers, 48 and 19, I'll end up with what this angle is. And of course, if I know what that angle is, then I know all the angles on that triangle. And this angle would eventually give me 23 degrees. So now I'm going to pull that triangle out over here. If I have a right angle, I know this is 38, I know this is 23. I don't even need to know that angle, but of course these have to add together to give me 90, so this would give me 67 if I wanted it. I'm looking for that side length. I can use my SOHCAHTOA stuff, my tangent, sine, cosine, whichever trig function I want. Let's say I want to use this angle. Well, according to that angle, I have the side opposite. I'm looking for the side adjacent, so I would want to use the tangent. So I'm going to say the tangent of 23 is going to equal 38 over x. And now I just have to solve. If I multiply both sides by x, there's going to be an x over here. I would eventually want to divide by the tangent of 23. And so now I'll pull out my calculator and I'll type that in. Make sure you're in degree mode. We should be. But I'm going to type in 38 divided by the tangent of 23, hit enter, and it tells me that that distance is approximately 89.5, and we were talking about meters. So that distance is approximately 89.5 meters. So again, anytime I have a right triangle, especially if it's off kilter like this, I like drawing a rectangle around it and just filling out as much information as I can until eventually I get an angle that I want. Had I kept doing this, like this is a 90 right here. If this is 71, then I know that this must be 19. I could continue to start filling out information. If this is 48 and this is a right angle, then I know this must be 42. And if this is a right angle, then that must be 48. And then eventually I can find this angle. So I mean, I can keep going until eventually I'm going to find something I want. All right, let's go back to letter B then. It says find the bearing from A to C. So they want me to start, here's A, here's C. I want to know what is that angle. Well, we actually kind of found it when we were talking before. Since we know that this is north 48 degrees to the west, this would be north 42 degrees to the east. So for part B, it's north 42 degrees east. It can be a little confusing, but hopefully you're able to follow that. If not, you're always welcome to come in. See if you can apply what we did here to number 33 and see if that'll help you out. All right. Problem that gives everyone trouble for the most part is number 34. This isn't number 34, but again, it's very similar to number 34. It says two towers are 40 miles apart. Forgive my drawing. Here's Tower A and Tower B. Where A is due west of B. It says a moose, which is right here somewhere, is spotted from the two towers, and the bearings from A to B, or from A and B, are east 21 degrees north, which is giving us this little angle, and then west 42 degrees to the north, which is giving us this angle. And you'll look at 34, they give you the picture exactly like this. It says find the distance D, which is this distance here. All right, and what I have to kind of recognize when I look at this is I think we can easily see there's a right triangle here, and then there's a right triangle here. What I notice in this problem is that those two right triangles share the same side length, and it happens to be the side length I'm looking for. What that kind of tells me to do is it tells me to use a system of equations to solve this. So what I'm going to do is I'm going to just look at this one for right now. Now, in order for me to set up some sort of sine, cosine, tangent stuff, I need to know that distance. I have no idea what it is. So what I'm going to do is I'm going to call this distance x, and then since the whole thing is 40, this will be 40 minus x. And now looking at this triangle, let's pretend like I don't know how to find that. Using the 21 they gave me, I have side opposite, I have side adjacent. I can say the tangent of 21 degrees is equal to d over 40 minus x. Alright, and that's wonderful and it's great, but I have two variables here. And normally if you have an equation with two variables, you can't really solve one of them. Imagine if I had that equation, I said solve for x. So I don't know what it is unless I know what y is. So the trick is, if you had something like that, remember when we solve stuff like this, now if I have two equations with the same two variables, well, then it's like a system of equations. I can try to eliminate the y variables by multiplying everything by 2, solve for x, and then back substitute. That's the idea I want to use. I've got an equation with two different variables. I need to come up with another equation with the same two variables, and that's going to require me to look at this triangle and do the same thing. I've got the 42 degrees, so what if I said the tangent of 42 degrees was equal to opposite, which is d, over adjacent, which is x. And now what I can do is I can easily solve for d and then substitute that in for d up here, or I could solve for x if I wanted to and substitute in here. Doesn't matter. So let's say I pick this one and I solve it for d, since it's pretty easy to solve for d. Cross multiply, I'm going to say that d is equal to the tangent of 42 times x. And now I can take that and substitute it into this equation, and of course that'll get rid of all the d's. So again, if you need to rewind that and kind of run through that again. Again, how I know to do this is that I have two right triangles, they share the same side length, and it happens to be the side length I'm looking for. That's what kind of tells me to do this. Alright, so I'll run through the calculations again. Yours numbers will be different, but it's very similar in terms of how you do it. I have the tangent of 21 is equal to, d now we said is the tangent of 42 times x, divided by 40 minus x. At some point I'm going to have to pull out a calculator. I'm going to cross multiply. So I have the tangent of 21, whatever that number is, times 40 minus x is equal to the tangent of 42, whatever that number is, times x. And so I'm going to pull out the calculator now and help us do some of these calculations. So tangent of 21 is going to be, and like I said, I would probably go out 4 decimal places. So 0.3839 times 40 minus x is equal to the tangent of 42. And again, going out 4 decimal places is 0.9004x. I'll go ahead and distribute. So 0.3839 times 40 is equal to 15.356 minus 0.3839x is equal to 0.9004x. So all I did is I figured out what those two were as decimals, and then for this one I distributed into that quantity. And now I know it doesn't look anything like 5 minus 3x equals 6x, but it's the same thing. You have two x terms, you need to combine them or get them on the same side. So I'm going to add the 0.3839 to the other side. So if I have 0.9004 and I add 0.3839, hit enter, looks like I have a total of 1.2843x on the right side. Left side I still have the 15.356. And then of course I want to divide both sides by 1.2843. So 15.356 divided by 1.2843, hit enter, and I'm going to figure out that x is approximately 11.9567. And we were talking about miles. And now what most people are going to do is say, okay, I've done all this work, I got my answer, thankfully I'm done. Well, not quite. I didn't do anything wrong necessarily, but I said that x is equal to 11.9, let's say, or 12. That's what x is. That's not what they asked me to find. They asked me to find d. I need to know what that is. Well, if you look right here, either one of these two, whichever one you want to, or this one I guess actually would be better yet, you can easily plug the 11.96 in here to figure out what d is. So I'm going to do that. I'm going to take that 11.956, I guess I shouldn't have cleared it off my calculator, 11.9567, and I'm going to multiply that by the tangent of 42. And that will give me the d, the number I'm looking for. And it looks like d, the answer I actually want, is approximately 10.76586 miles. You don't need to round the final answer. You can round it to 1 or 2 decimal places. If you want to go out that far, you can. Now, to prevent you from doing all this work and then end up giving that for an answer, because it's a common mistake to do that. It's a lot of work that you did. You probably figure you're done. When I did my substituting, I could have solved for x and then plugged it in here. So I could have, for example, put x over here, divided, and said that x was equal to d divided by the tangent of 42. That's a little more messy, but that would have given me the right answer right away. Again, that's exactly what 34 is going to look like in terms of your solving, so if you need help, see if that'll help you out. Last one. Alright, for this last problem, we have a lighthouse 350 feet above sea level. Observer 2 ships directly offshore. Angle of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? Alright, so I might start by drawing your lighthouse here. We'll have one ship here, and another ship will be out here. If I draw a line from that lighthouse to each ship, when they talk about angle of depression, if you were standing on that lighthouse looking horizontally, the angle of depression would be the angle that you would see when you look downward. So when they say there's a 4-degree angle of depression, it would be from the horizontal down to that line. So this is my 4 degrees, and then this would be my 6.5 degrees. Alright, and so I'm going to use right triangles to help me solve this problem. Now, knowing what I know about geometry, I know that if I look at this triangle here, that essentially is the same thing as this triangle here. And I would be looking at an angle of 4 degrees here, which means this is also 4 degrees. So I know this is going to be 4 degrees. And what I would like to do is I would like to find this distance and then my plan is to look at the other right triangle that I have sitting here. If I looked at, oh, I guess, sorry, that would be this distance that I'm looking for here for that red triangle. Now if I look at the smaller triangle right here, now I will look for this distance. And again, knowing what I know from geometry, if that is 6.5, then that means this should be 6.5 degrees. And so I'm going to end up solving two different triangles, and then I'll just look for their difference. That'll tell me how far apart the ships are. So if I look for the smaller triangle, or the one that's in blue up above, I know I've got an angle of 6.5 degrees here. I know that the observer is 350 feet above sea level, so this is my 350, and I'm going to be looking for this distance. And so given this angle, I have side opposite, I'm looking for side adjacent, I know to use the tangent. So I'll say it's the tangent of my angle, 6.5 degrees, is equal to 350 divided by x, multiply both sides by x, and then go ahead and divide by this number. And make sure that your calculator is in degree mode, or of course it's going to end up giving you the wrong answer. So you take out your calculator. Remember to check your mode is right here. Push that button. We are in degree mode, so we're okay. If not, make sure you go down to degree, hit enter. And now I'll just type that in. So 350 divided by the tangent of 6.5 should give me approximately 3,071.910575. So there's that distance. And then if I take a look at my drawing and I look at the red triangle, you'll see that it's essentially the same thing. Still have a distance of 350 feet above sea level. I want to figure out that distance. This time my angle is 4 degrees. And again, looking at this particular angle, I know the side opposite. I'm looking for side adjacent. I again want to use tangent. So I'll say the tangent of 4 degrees is equal to 350 divided by x. Exact same steps, multiply both sides by x. Divide by whatever the tangent of 4 is. So again, I'll need to use my calculator. And so I'll say this time it's 350 divided by the tangent of 4 and hit enter. And it looks like this one is approximately 5,005.23319. And now, like we said before, I know this distance here is 5,005 approximately. I know that distance is 3,071. Now I just need to subtract them. So subtract that number, and that should be the distance between the two ships, 1,933.32 feet. So again, notice how I used right triangles to help me solve my problem. In this section, you should be trying to come up with right triangles to help you figure out your problem, and then using your SOHCAHTOA. All right, if you have questions, feel free to ask in class or before school, after school.